evening. Welcome everyone to the closing event of Digital Futures 2021, Inclusive Futures workshops. I would like to thank all of you, all the audience here who with us in the last few weeks, including the instructors, students, and all of those who participate and contribute in the Digital Futures 2021 series of events. From the first ever Digital Consortium PhD program to our traditional annual workshops, it is your work, your dedication to this program that constitute the very foundation of Digital Futures Association. It is your participation as well as our organizing team who worked tirelessly putting this together pieces by pieces that make the year's Digital Future event such a wonderful experience to all of us. Firstly, I would like to allow me invite Associate Dean of College of Architecture and Urban Planning from Tongji University to give the opening remarks for our closing ceremony. Let's welcome Professor Wang Lan to give us a speech.
Hello, everyone. Thanks, Philip. Distinguished professors and dear students, honored speakers and presentators, good evening. It is my great pleasure to join this. On behalf of the College of Architecture and Urban Planning at Tongji University, I welcome you to the closing ceremony of Digital Future 2021 summer events. Digital Futures is one of the most important annual academic events at our college. I cannot believe that it has been held for 10 years. The Digital Futures initiative has been promoted the theoretical and scientific research on computational design and robotic fabrication. Over the past decades, this program has launched itself from a small local event to a true international global impact, international collaborations. I think during the whole process, the diligent work of Professor Philip Yuan, Professor Neil Leach, and other founders and all participants has been devoted to this whole process. This year, the Digital Futures program has formed an unprecedented large community. I believe it started a new chapter in the development of global knowledge collaborative. I hope that the Digital Future Association will contribute the work that we are all benefiting from. This platform has the potential to unite us all in a true global classroom. As the Inclusive Futures theme suggested, to share, to collaborate with a global spirit of solidarity. So congratulations to the instructors and students on these fruitful workshops, and congratulations to Digital Futures on another year of success. I believe you made a difference. Thank you.
Thanks a lot to Professor Wang Lan for your kind words. So it's a great thanks. Digital Future is starting from Tongji, but right now goes to the world. We have a lot of organizers, including Neil Leach and me, and also we have a very big team. And thanks a lot for all the organizers, participants, coordinators, and also we have different directors in different Digital Future hubs. So without your efforts, we cannot organize such a great event. And there were so many students all over the world from all different institutes participate in the wonderful past 3 weeks, including different kind of PhD courses and also the wonderful workshops as well. Today, we draw a conclusion to our Inclusive Future Summer workshops. The final chapter of the Digital Future 2021, since the program's very beginning in 2011, the Digital Future platform has been an organization aiming to offer free education open courses, open education, and accesses for all across the world. Growing from a small local event to the truly global phenomenon this year, the Digital Future community continues to expand, drawing people from all corners of the world, together with the singular platform to generate new opportunities for access, equity, and spread of architectural knowledge. This year, the Digital Future program offered again a great variety of opportunities and experience to promote discussions at a broader range of levels, skills, and topics. Now it is briefly take a look at some of the highlights from the entire Digital Future 2001 program. So I would like to present Neolich and me. We are the co-founder. Actually, over the past 11 years, it's a great honor to give a special contribution to all the society. And this year, I think most especially want to highlight is the PhD Consortium doctoral platform. And in addition to the traditional workshops and conference, we kick off this special series, event series, with sharing or opening doctor education platform, which features various lectures by leading scholars, researchers, and participants in their respectful fields. And at the same time, on this platform, most importantly, we not only make event for workshops, exchange ideas or knowledge from different talks, but also most importantly, we want to set up a special conference. The name is Computational Design Robotic Fabrication, CRF, from actually, which is starting from 3 years ago. This is the 3rd year conference. I think we want to publish all the workshop research and publish your thoughts on this academic platform. So the research papers normally focus on the digital technology of architecture design and construction. The theme of the paper includes, but not limited, the architecture theory, tools, methods, and procedures in architecture intelligence. And this year, the 3rd International Conference on Computational Design and Robotic Fabrication started off with a keynote lecture by Daniel Bolligen. Proceeding includes presenting on a large, wide range of subjects, as well as the 2 other keynotes by Jules Rasting, Matthias de Campo, and Sandra Manning as well. We are able to see some of the most novel student research done in the digital realms of the architecture. So the main topic of CDRF this year is material intelligence. And you make a discussion with me, he wants to add e-material intelligence. I think it's kind of dialogue right now in the digital design. It's interestingly, the artificial intelligence and the material intelligence integrate with each other. It's kind of dialogue from the virtual world to the material world. So it's interestingly make this discussion through our special events. And I would like to briefly introduce the submission, selection, acceptance rate through CDRF platform. Since the first conference in 2019, we witnessed a steady increase in submission numbers and the stability scale as the conference enters its 3rd year, touching on new subjects, raising new discussions. At the same time, we publish these scientific papers, and which is totally open access and sponsored by Tongji University and Tongji Architecture Design Institute. Why open access? Because we want to introduce all the research papers to the public, which you can download freely. You can see architecture intelligence is downloaded over 6,600 times, and the others all have very good performance. And the next book sequence is coming on in the next over the next few months. We want to organize the special book of material intelligence of this year. So this is actually the important publication. and which strongly supported by Tongji University and Springer Publication. I think great thanks to all the contributors and all the sponsors. I would like to bridge the workshop culture, digital future talk culture to the academic publication. I think it's important to help some young generation to scientifically or academically publish your research. I think which will help a new generation growing up in the future universities, in the future academic world. I think which is another new motivation we want to contribute through this platform. And next, this year, actually, we want to introduce inclusive, the hybrid workshops. In the time now focus on recovery and revitalization, the workshops adopted a hybrid format with online workshops, hybrid, and in-person courses going complementary to each other, giving students a wide range of options in the 109 workshops that we offered, and the in-person workshops, which featured on-site constructions, have yielded terrible results, terrific results with their production. Actually, I just come in from the campus because we have different difficulties to finish one or two different pavilions. Although the climate is raining, so I think it's too rainy in these few days, which actually give all the participant students a lot of pressure. But still, I think it's a terrific process for us to teach and learning from all the participants to this physical robotic fabrication workshops. Here we have a complication of clips of Digital Consortium lecture series, the CRF conference, and some physical workshops. So I would like to invite Li Keke, would you please to sharing some of the videos of the workshops right now? I want to quit the, is Cara here? Would like to sharing some videos.
Do you want me to start now, Philip?
Hi, you can keep introduce.
Yes. So thank you. Welcome to the closing ceremony. I find myself reflecting on what was happening exactly 12 months ago when we wrapped up the extraordinary event, Digital Futures World. This was something that, of course, came together because of COVID. The idea was to bring together architects and instructors around the world in a spirit of solidarity to offer something very special in a very difficult time. But what came out of that astonishing event was really something very special. We realized that not only had we managed to, in some senses, break down the walls of the classroom and begin to share educational ideas across the globe in an incredible sort of way, but we also began to realize that in some senses, without maybe intending to, we had begun to sort of democratize and revolutionize architectural education. And as a result of that, we decided to keep the platform alive, to keep it alive as a year-round kind of a platform for the dissemination of knowledge. And from then on, every single Saturday, we hosted an event, a panel discussion, a series of lectures, and so on. Remarkable in the standard of the presentations, and remarkable because it became a repository of knowledge to be shared for everyone around the world. This summer, we were then kind of faced with a situation, what to do, and it struck us really that while we had made some considerable contributions, at the same time, the world is not equal. The world is still divided in many ways. There's a privileged parts of the world and there are less privileged parts of the world. Even the vaccination has not been shared equally around the world. So we took it upon ourselves to launch another event, an event that is in a sense also growing out of the social changes that happened during the pandemic, the Black Lives Matter, the social changes, and the idea about being much more inclusive in the future. And so as a result of this, we have this astonishing event, Inclusive Futures, which goes way beyond the initial experimental and highly successful event last summer to become something that is a genuinely international and inclusive event. This would not have been possible, of course, without the incredible contributions of the instructors. And I just want to thank everyone for your contributions. This wouldn't happen without you, and indeed without the students who joined us to be part of this. And this is a remarkable, I think, display of solidarity and passion about architecture and ideas behind architecture. But I want to draw attention to a particular group of people who have been behind the scenes making Digital Futures work. And Digital Futures, as it's emerged from a kind of an annual conference in a physical space to being an international platform that's alive throughout the year, wouldn't have been possible without this group of people who are all volunteers, volunteers from all over the world. I mean literally all over the world. We have representatives in our team from every single continent, apart from Antarctica, and no doubt next year we'll have somebody from Antarctica. But this year, for the summer, we divided up responsibilities. So we had a member of the team responsible for various parts of the world. Ahmed, for example, was responsible for Africa. Aya Riyad was looking at West Asia and Middle East. We had Nick Bao in charge of Australia, Riffle in charge of India, Chao Yan looking after China, Antonio Banacci and Maria Kupsova were looking after Europe, Marina Rodriguez das Neves was looking after South America. And then in the States, we have Gustavo and Virginia doing an incredible amount of work. I'm not going to single out individuals to thank you for what they've been doing, but I think we all know who did who put the most work in. I would also like to thank Biina as well for working behind the scenes. A number of others who have also been active throughout the year, Cena and Theodoros, Victoria, and a few others. I'm probably missing out a few names. I just want to thank you all for that. It's been an astonishing event. I also want to welcome Mohamed Bejo and Misbah, new members of the team. As it's like the team performs like a relay with new members coming in to support when other members find themselves obliged to pull back, to withdraw. It's been an astonishing contribution. I sometimes refer to this as the iceberg team, in the sense in an iceberg you only see 10% of the iceberg. With this, you only see maybe 1% of the work that goes on. It's truly an astonishing contribution. An amazing contribution, given that everybody's volunteering their time for free for the sake of other people. It's almost, in some senses, a bit like United Nations. We are completely universal, but unlike the United Nations, we operate in a completely democratic way, in that nobody has the power to veto the decisions of other people. And on occasions when we voted on things, I've been voted out on certain things. And that's the way that democracy works, and that's the way that it should work. This year, of course, we had a significant development in this in the terms of the Digital Consortium. This, to my mind, is potentially something that's going to have a huge impact in terms of doctoral education worldwide, and also those who would wish to undertake doctoral education, to be more inclusive about it. The Digital Consortium really it came out of what we began to realize was happening already. It was happening in the sense that we were beginning to discover that the old models of the past really made no sense. It doesn't make any sense anymore for a single professor in a single classroom to talk to a single group of students, when we could be sharing knowledge, when we could be drawing upon the very best in the world to come and give lectures and so on. And this is what happened. This is what happened over the summer. We began to develop this thing in a new way. We've been testing it out before in the Florida International University DDES program, but now it became a reality. And I have to say, I was astonished by what came out of that. A truly remarkable operation that really began to point out the limitations of doctoral research normally. in most universities. There are very few universities where you can really cover the subjects for a doctoral program, maybe MIT, Harvard perhaps, but most places don't have those resources. So it makes complete sense to share resources. And also from the point of view of these individual researchers, and I think that a PhD, a doctoral program can be a very lonely enterprise. It gave the possibility of something to happen which would bring people together to share knowledge in an interesting new way. And that, to my mind, was really remarkable. What we've then to achieve then is to develop a kind of platform that in many ways is reinventing what architectural education it can be, that's opening up possibilities and is challenging the existing exclusionary mechanisms. Not only have we been inclusive in terms of the team members from all over the world, but also in the possibility of making access ideas available to everyone throughout the world. The mantra we have throughout what we've been doing is the idea that education should be a human right and not a privilege of the wealthy. And I think we're doing that. We're achieving it, let's say. We're only halfway there, but we're achieving it. We want to change the world, and we're trying to get there. And I think one comment that was made by Philippe Morel, I think, which is kind of sums up in some senses what we're trying to do, and that is to say, he compared what we're doing to the way that Uber, or indeed Didi maybe in China, is revolutionizing the way that has revolutionized the way that taxis operate. The world of taxis has been forced to improve its act, and so too we're hoping that we will be able to introduce new innovations to standard architecture education, and so too to maybe introduce a culture in conferences where the ridiculously high fees that are being paid that exclude many people from around the world are being overcome. Nothing gives me greater delight than the fact that we're offering all these services, all these things for free, and that's remarkable. So we are this kind of team, a team from all over the world that in many ways, many very different points of view, really completely different, but we are united, I think, in a number of areas. We are united in our passion for architecture, and we're united in our passion to try and change the world and make it better. And nothing gives me more pleasure than to see what is coming out this year. Of course, we haven't fully understood, haven't fully made sense of what's happening. There have been some challenges. There's been some technical challenges. We lost Wolf Pricks during the opening ceremony, but there have been some astonishing successes too. And over the next few days, next few weeks, I think we'll be trying to reappraise, to assess what has happened and to think about how we're going to take this forward. And for sure, Digital Futures is here to stay. It's evolved in something that I think is going to have an enormous contribution towards architectural education worldwide. One of the things that gave me great pleasure, and I think also Chao this year, has been the introduction of theoretical debates. I think that the discussions that we had in the Digital Consortium, bringing together some astonishing figures, not just Slavoj Žižek, the kind of rock star of contemporary philosophy, but also the very charismatic figures like Manuel de Landa, Sanford Quinter, Erin Manning, Ana Maria Duran Callisto, and so on. A whole group of people who have come together, and really an astonishing set of debates, and viewed by an astonishing number of people. Last time I watched it, I saw that Slavoj Žižek had been viewed well over 10,000 times. And it's in that spirit of promoting not just physical workshops, but also ideas and the theoretical approaches behind them, that one of the most important innovations that we've done this year as a group, it was voted on within the team, is to introduce an award for theory. And this year we introduced the first time an award which is named after the hugely charismatic figure of Mark Cousins. I contacted Parveen Adams, his widow, to get her permission to put Mark Cousins' name on this award. And this is something I think that's going to hopefully open up a new level of debates about the theoretical content in architecture. For those of you who don't know, Mark Cousins was an incredibly charismatic individual who operated in many ways a bit like Digital Futures. He would give lectures at the Architectural Association in London on a Friday evening that were open to everyone. And people did come. They came from all over London to listen to this. Some extraordinarily charismatic and influential sort of lectures. And Mark Cousins, I should say, was also responsible for launching what's known as the London Consortium, a PhD program, a nomadic PhD program that involved the Architectural Association, where he was teaching, and a number of other institutions in London, which became the model for many subsequent PhD programs, including the Digital Futures one that we launched here, and also to some extent the Digital Consortium. The name Digital Consortium comes from the London Consortium. And so one thing I noticed has not been scheduled in our schedules today, but I would like to take the time now to begin by giving the first award for the evening, and that is to give an award to the recipient of the first ever, the inaugural Mark Cousins Theory Award. We put together a team that was chaired by Sanford Quinter to think about who could best represent that. And we decided to give the award to Alexandra Jaiska of the University of Texas in Austin. Maybe we can get Alexandra to switch on her camera. I don't know if that's going to be possible. I should say that Alexandra she's an assistant professor at the University of Texas in Austin. She was born and raised in Poland. She has a Doctor of Design degree from the Harvard GSD and a diploma from the AA in London, where I knew her years ago. Her interests range from ecological science and thought through definitions and models for sustainability in architecture to systems theory and cross-scalar integrative design strategies. Her doctoral dissertation on the green apparatus, the ecology of the American house according to building codes, investigated how building regulations coupled with green building technologies and incentives shape environmentally driven design and environmental awareness. And a book based on her dissertation is forthcoming from Princeton. Alexandra was also the winner of the Harvard GSD 2019 Wheelwright Prize. What we enjoyed very much about Alexandra's work was not only the fact that she had been addressing these important environmental issues, but also that she was kind of really introducing new ways of thinking not as theory as such, but really as a kind of working operative way of operating, thinking architecture itself. So I'd like to, on behalf of Mark Cousins, in memory of Mark Cousins, keeping alive the astonishing contribution that he made, selfless contribution to architectural culture, I'd like to present the award to Alexandra. And I know that Alexandra herself was privileged to be able to have listened to Mark Cousins at the Architectural Association while he was teaching there. So maybe, Alexandra, first of all, congratulations. And we really respect the work that you've been doing, important work that really fits in very closely with our overview of what digital future should be about as an inclusive, but also an environmentally aware site of debate. Welcome.
Thank you so much. Can you hear me well?
Yes.
Yes, okay. First of all, I've said that before to you, Neil, I'll have to do a lot of really thoughtful thinking and writing to deserve a prize given in Mark Cousins' name. His Friday lecture set the rhythm of the days that I spent at the AA as a student, as you mentioned. And I do think that there are really many, many theorists out there who deserve this prize more than I do. But of course, I truly appreciate this recognition, and I take it as an encouragement. So Neil, Philip, and everyone else at Digital Futures, thank you. And Sanford, I did not know you chaired the jury. Thank you very much. Now, if there is a couple of minutes, I can say a couple of words.
Yeah, go ahead.
Okay, perfect. So, I asked myself when I started in this period writing and found out about this recognition, what does it mean to be a theorist? I have been really reluctant to accept this label because I see myself as an architect who, to some degree, disappointed by by the profession, has taken a break from design to search for another way to practice. But also, since I now teach, to help students of architecture to push the boundaries of how they will one day do it. And so I started to be more comfortable with the idea of contributing in theoretical ways only when a friend suggested that theory meant providing frameworks that, to some degree, emancipating oneself, as he put it, requires a conceptual map. And I thought, okay, so to untether yourself from the common ways of thinking and hence doing, you need a set of principles, a procedural almost protocol, a map. And I started to think of theory as a form of map making, which made me feel much more comfortable. Now, you don't need a map if you actually go places that are already known to you, the ones commonly visited by your peers. But if you feel that pushing the boundaries, and I don't mean it in a way that a fashion-obsessed provocateur might mean it, I mean it in terms of ecological and ethical boundaries. If your gut is telling you that pushing those boundaries is necessary, then you need a map. Now, you can take a stick or a paddle, or as Sanford Quinter would put it, a machete, and plow your way through whichever uncharted territory you decide to explore. But the path will disappear as quickly as you've made it if you don't make a map of it. Not only you might get lost, but also, and perhaps more importantly, the journey will isolate you from your community if you don't somehow share the gained insight with your peers, which is exactly what you're doing now. Perhaps this is a way in which one can think about theory so that it's adventurous, it's dynamic, but it's also collaborative and embedded in the biophysical and intellectual environment. Now, to my mind, a fascinating aspect of every theoretical investigation worthy of the name is that it actually combines venturing into the unknown, this kind of speculating straight from your gut, as I like to think about it, and at the same time, attaching yourself to the webs woven by other minds. That is especially fascinating, of course, when the minds that is your mind, my mind, and the other minds are co-fabulating in a synchronized way that is more or less at the same time as we're doing in this fascinating period, all in part thanks to you because of the platform you created, but also recently thanks to Cynthia Davison and her logarithms. But there is also an act of reviving the energy of the mind set in type, so to speak, the minds that you find in books. Now, when I did my PhD, or my doctoral dissertation, I should say precisely, the initial criticism was that I was venturing way too far into an old growth forest of forgotten thoughts and events and minds. I insisted that this was the only way to do it, with the risk of failing, wasting thousands of borrowed dollars, not to mention not getting a Harvard diploma. But I knew of no other way to undo the dogmatic ideas about sustainability, green architecture, and energy efficiency than getting out there into that forgotten world of past minds to ask them. I know some will say, just go and participate, practice. It was not my way. Now, I needed to think. Now, I had my intuitions, but I also trusted a couple of incredibly creative minds that are active in this period. And of course, I was fortunate enough to know personally and have him as my professor, Sanford Quinter, who I simply trusted, and I trusted the hints that were offered to me to start the journey, and of course, other minds as well. Every single lead from those minds was precious. I know that these leads, I knew they would somehow spread like a rhizomatic root system, and they did. So I drew a map for myself, a map that I keep on redrawing to make sure I don't fall back into the commonly spread ways of thinking about sustainability and the environment. I want to emphasize briefly another issue, that I think creating theoretical frameworks or maps is not a purely intellectual or cognitive process that can be somehow, that can happen in vitro in an isolated brain or inside a computer. It's about activating your perceptive and emotional capacities, but it's also about that gut intelligence and spirituality as well. And the map must be at least three-dimensional: intellectual, spiritual, and ecological, if not simply biophysical, which in itself has many dimensions. I, for example, do a lot of thinking when I walk. Somehow the act of walking in the environment, not in front of the computer, triggers a particular type of creative, although crude, thinking that I'm raw thinking that I'm convinced is only possible due to the constant coupling of the brain and body within the environment. The dimensions of the thinking process, they need to keep on, they expand if you think about it. If you consider also the fact that ecology in itself and interrelatedness must consider energetic, material, and informational processes to be complete. So thinking about these processes on another level also requires involvement of the bodies, minds, and spirituality. And I think this is where the last component, something that is really hard for us to deal with, is where our ancestral or indigenous knowledge comes in as a helpful map that we should be trying to retrieve from our collective memory. And I think that intellectual activity is normally considered something that we do in a controlled, aware way. You need to know where you're going or what you are looking for to make a map. But I think to add another dimension to it, there's another way, and that'll take me to Mark Cousins. You need to know, it's almost like drifting with others, surfing along other minds. It's meditating on the map-making process that other thinkers offer to you when they decide to publicly share their journeys in speech or writing. And by the way, of course, those acts are also creative acts. They are not just representation of something done earlier. Now, how do you meditate on a lecture, for example? I think you simply allow it to affect you on other than intellectual levels in ways that you might not even understand, but might sense as forms of vibrations. And to me, Mark Cousins' lectures did that. I did not always, if ever, understand them at that time, but they worked at that deep level. They taught me that testing ideas and articulating thoughts was a way to diagram potential directions. It was a way to question the boundaries of our discipline, even if we did not know as students where these boundaries were. Now, what are the minds that we should be co-theorizing with? For me, in this period, it's scientists, spiritual leaders that I look to for leads. And I think architects really need voices from the outside of our discipline. Otherwise, our discipline will simply atrophy. Neil and Philip, thank you for creating this platform and for seeing, Neil especially, for seeing potential in my research in intellectual map making. I want to thank Sanford for allowing me to tap into some of his mental maps. And I would really like to thank Victoria Barber, who involved me in the first conversations on this platform. Victoria, I think you deserve this prize much more than me. I have become a kindred spirit, and well, Victoria has become my kindred spirit, a kindred mind. And to Mark, I hope that you're smiling, or at least not frowning. Your Friday lectures were like a mantra to a young meditator, trusting that not understanding does not mean not learning. Thank you very much.
Thank you, Alexandra. I mean, I would simply say that when I asked Parveen whether she would mind giving an award in Mark's name, she said Mark would be delighted, and I'm sure that he would be delighted. And I would also say that when I was teaching at the AA and when Mark was there, I think the theoretical debates are what fueled the incredible culture of design at the time. Neri Oxman and Akim Menges were among the highly talented students that were at the AA at the time. I just want to mention before handing back to Philip that we, of course, made 3 other awards during the opening ceremony to Wolf Pricks of Corp Himmelblau for Deep Himmelblau, to Virginia Sanfratello and Ron Real for their Tita Toto wall installation on the US-Mexico border, and to Felicia Davis, who was the author of an astonishing project that's very much the icon, like a spider's web itself. And I want to just finally say that I think that's almost a mantra for what we're doing, Alexandra. Your description of webs woven by other minds is really a beautiful way of putting what we're trying to do here. Thank you, Alexandra. Over to you, Philip.
Thank you.
Okay, congrats to Alessandra. It's a great honor to have you here. And I think theoretical thinking and theoretical research is always important to the academic discipline. And especially right now, digital thinking redefine the world, redefine the thinking methodology, and redefine the ways how we make communication, and also redefine the way how we engage ourselves to the social process. So I think it's a great honor to have you here. Congrats to your contribution to the academic theory. Thanks. And then I would like to announce another award. We name is Coding Award. It's the hardcore of the digital culture. Actually, I think the authorship of architecture is in a huge transformation over the past decades. It's importantly, the authorship is not just from the human mind. It goes to a new collaboration between the machine and human. So the plugin software and also the coding becomes one of the extension of the human thinking, human thoughts. And also the coding is one of the most important platform, which give us a new opportunity, especially towards architecture design and engineering roots itself in the computational technology, software and methodology. The design method continues to evolve and redefine the tools at hand, and also which expanding the human thinking skills and also the crafts of the human skills. Digital Futures Coding Award is awarded to the most influential digital tool in the field each year. And this year, it's a great honor for us to represent the award to the paneling tool for Rhino and Grasshopper developed by Raja Isa at Robert McNeil and Association. So congrats, Raja Isa. The paneling tool software is widely used to rationalize the freeform surface and create the paneling solution from concept to fabrication. The development of paneling tools started in 2008 as a plugin to Rhino NURBS modeling with two goals in mind: to support quick mockup of paneling idea and to prototype and fabricate the final the panel solutions into the physical reality, making a smooth transition from design and production. The further development of paneling tool inside the Grasshopper parametric environment allowed powerful control over paneling and pattern variations. The paneling tool intuitive and the parametric capacities make it popular across many sectors of design industry, such as the jewelry design, consumer products, film, and building industry as well. And its versatility and seamless integration with a leading 3D modeling and the parametric design tool make it popular worldwide in academic and practice as well. Unfortunately, Raja is unable to join us today at the award ceremony, and she kindly pre-recorded her lecture for us to formally introduce to us her work and achievements, and will give us a brief overlook on the panel tools. Let's welcome Raja.
Thank you, Digital Futures, for honoring me with this award. I'm truly humbled. My personal story as an Iraqi woman who was forced out of her ancestors' homeland because of violence, only to find a global audience to her ideas, is nothing short of remarkable. I'm immensely grateful to all the people and places that helped me be here today. I'd like to extend this honor to Robert McNeil and Associates for taking a chance on me very early on, and for their incredible vision, insisting on excellence and community, for providing a safe and fertile ground for many brilliant ideas to flourish and take hold. Most importantly, I think the real reason why Paneling Tools is honored today is because of our passionate users who have been relentless in their criticism of our work throughout the years, and for occasionally reminding us how it changed their own lives. In hopes of inspiring minds more creative than mine, please allow me to share a small slice of my journey with Paneling Tools and how it came to be. I have a background in both architecture and engineering, and have always been fascinated with tools as conduits for creative expression. When I understood the creative design process as a reflective flow between the mind and the product, it became clear to me that the medium should facilitate an unobstructed flow between the designer and their creations. My curiosity about digital tools started some 23 years ago when I was a graduate student at Auckland University in New Zealand, looking into digital methods available at the time and how intuitive it was to create pattern concepts. It was clear that these tools were not designed with the creative design process in mind. The whole concept of paneling and pattern generation was dismissed as a detail to be added later in the form of textures. Using these tools did not support paneling as a starting point of any design concept. The realization that no good tools were available to help creative design started me on a road to learn how to write software, and later conceived a digital tool to create paneling solutions from concept to fabrication. For any creative design tool to be successful, they need to satisfy 4 requirements. They need to be useful. That is, they fill a gap or solve a problem. They need to be intuitive, easy to use, and fast to create with. They also need to be reflective. That is, easy to edit creations and instantly see the result. Finally, they need to be affordable. They have to be easy to find and access. There are abundance of patterns in nature and strong mental image in designers' minds about how they look and how they ought to look in their designs. But the problem is that they are time-consuming to express using any design medium. They are very time-consuming to edit and recreate, and it's really hard to build complex paneling solutions using traditional technologies. Many things changed in the past couple decades. Fabrication technologies shattered the barrier of paneling complexity and its affordability in building design. Yet, there was no medium available that supported designing complex paneling solutions that also communicated well with fabrication. Paneling tools for Rhino and Grasshopper simply filled that gap with an intuitive digital tool that is easy to use, edit, and access. It became an essential part of the designer's digital toolkit, whether to create a concept, communicate it, or build it. When I first started the Paneling Tools project, I had 2 goals in mind. The first is to support a quick mock-up of paneling ideas, and the second was to be able to prototype the concepts into physical reality, making a smooth transition from design to fabrication. At first, I did not have a clear idea about the specific flow or functionality. I only had a concept of a tool that was itself uncertain, and I used a reflective process to create it. It meant that I needed to involve the end users very early in the process. Paneling tools development followed a path very similar to that of any other creative design project. It started with a problem to solve, synthesized a concept prototype, then shared it with others for feedback. I actively listened to the user's suggestions, but most importantly, tried very hard to understand the workflow and what they liked to achieve. I weeded out undesired features and redesigned the flow and functionality multiple times. The work did involve many more cycles of prototyping, reflection, refinement, and full partnership with the users. Over time, paneling tools started to shape into a useful general tool to release. We documented the features, examples, and workflows, and shared it with the community. It is important to stress that I was afforded to develop paneling tools using this reflective cycle because there was a community of willing users to work with, and because I had access to a digital platform that was stable, open, and powerful. My designer background helped me internalize the uncertain nature of design, and my rigorous software training meant that I could build the tools without having to articulate any specifications. When trying to develop a pattern concept, designers start with either an inspiration or a process. The initial inspiration can be a picture, a terrain, a form, some flow, a scale, a pattern, or some other elements. Instant preview meant that the designers can reflect on their creation in real time. Paneling tools uses a 2-step solution: grid first, then panel. This gives maximum flexibility to develop paneling ideas intuitively. The grid helps set the flow and the scale quickly using various methods. Paneling patterns can be conceived out of connecting grid points, but also can be predefined modules. The output of panels can be in any geometry format. Designers can pick the one that is useful for the particular stage of design. At early stages of design, users can quickly synthesize their concepts with lightweight geometry. Once the concept matures, the tool allows creating more detailed panels on the expense of heavier models and slower feedback. Detailed panels can be made ready for fabrication through unrolling for laser cutting or turned into meshes for 3D printing. To give you an idea how paneling is actually built in practice, I'd like to share with you the paneling process in the movie Terminator Genesis. The set designer, Andrew Reeder, used paneling tools to develop and then build his paneling concept. He started with an atmosphere, a feel of space, but also took it all the way to fabrication. When building the actual set, the 3D models were passed to the contractor. It was in a mesh format. The contractor attempted to orient all panels to a flat surface, then projected the outlines to create the document for laser cutting. He quickly realized that this would be a very time-consuming process and asked for an alternative format. Since all panels were originally developed from 2D paneling grids, it was trivial to also provide the 2D panels ready to unroll for fabrication. The final set was a combination of physical and digital parts augmented to create continuous space. What started as an idea and experiment became a popular tool used everywhere, not just in architecture, but also in other design professions and during all stages of design and building. Thank you all.
Thanks a lot. I think it's a super hardcore code word, and I remember actually my studio years ago. We use your special plugin when you presented. I remember it's really interesting to keep me remind what's the software plugin give us. It's so great. Thanks to your contribution and the open access to your plugin to the Rhino community. So thanks a lot to your presentation. And the next part I would like to introduce, which is also one of the interesting part, we name it as a Young Award for Digital Futures. Actually, before 2020, we have a Digital Future Young talks offline on campus in Shanghai every year, and invited the most prominent, important speakers coming to Shanghai to make a lecture. But after 2020, when the event goes to online, we still think about this Digital Future Young award is very, very important, because the young generation give us new opportunities to develop the new plugin, new tools to the digital in architecture. With the Digital Future Young Award, we seek to honor and recognize the young scholars, researchers, and the professions that are changing the architectural field in this very moment. The youth is an extraordinary asset to not only the Digital Future community, but the entire world, benefiting from their energy, ambition, and talent. And this year, we have 4 recipients selected for the award. And the first I would like to introduce the Young Award is Cena Mustafini. Let us move on to the award winner. Dr. Cena Mustafini is the practicing architect, researcher, and educator specializing in computational design and architectural robotics. He holds a doctorate degree from TU Delft, where he has been a senior researcher and a manager at the Robotic Building Lab of Hyperbody Group in AE+T at BK City. He is the founder of Setup Architecture an award-winning studio that aims at adapting digital design to production technology to the geoculture specifics. He has led and taught numerous studios at the TU Delft and the Saal Institute of Architecture, DIA, at the Bauhaus, and where he has been the director of DARS Hub, Design, Architecture, Robotics, and System, which focus on delivering the interdisciplinary projects such as bioplastic robotics 3D printing and adaptive city car sponsored by Audi. Dr. Mustafini's project have been featured at international exhibitions such as the V2 Gallery, NAI Rotterdam, and the Paris Centre Pompidou. He is author of the book titled Hyperintelligence in Architectural Robotic Materialization, which centers on integrate design computation to robotic production of hybrid material system using the multimodal production methods. Lectured and published internationally, he has been a scientific committee member of various journals and conferences. Congrats, Cena, and a pleasure to have you here with us and the showcase for your welcome. Yeah, welcome. Yes, Cena here.
Thank you, Philip, for wonderful introduction. I'm really honored and glad to join this award and closing ceremony. So with this, I would like to share my screen and take the chance to share part of my journey and truly thank you, Neil, and Digital Futures team. So I will start sharing my screen. I hope you see my screen in full screen mode. Okay, I'm Cena Mustafini, and I'm extremely thrilled and humbled to receive this year's Emerging Scholar Digital Futures Young Award. I'm joining you today from Delft, the city that I've been lived, worked, and studied for the past 10 years. Born and raised in Tehran, I'm from Iran and Netherlands. Moreover, in the past 4 years, I had a chance to work in the Saal Institute of Architecture at Bauhaus campus in Germany. In this presentation, I'm going through several projects that I've done in practice, research, and education. I would say that the boundaries between these three realms of research, practice, and education are rather blurred, but I will start with my journey in practice. I'm the founder of Setup Architecture Studio, as Philip mentioned, a studio which is concerned with combining and integrating or adapting digital fabrication and design technologies with geocultural specificities. As you can see in this project, Soft Stone, we are combining local craft of soft craftsmanship with digital design and fabrication. And then the result is a kind of transition from a very rigid body of stone to soft, as you can see in this facade. And it also continues to the landscape and creates this fluid feature in the design. So with this concerns with on digital design and fabrication on the one hand, and learning from crafts and local culture in design and construction on the other hand, I'm also very much interested on the way we can redefine the role of ornament and tectonics in building and construction. And at the same time, I'm very much interested on how we can look beyond the finished and commercial building products or materials by looking into sequences in construction and constraints and potentialities of different production setups, how we can learn from the history and how we can learn from other industries such as automotive, and what do they bring to architectural constructions. And at the same time, I'm very much interested on the way we materialize our buildings. What are the fundamental differences of subtractive approaches versus additive, and how these differences will redefine the past and present applicable models or future visionary models with which we can materialize architecture. in this context, materializing architecture, what is the role and impact of design media? And in an interdisciplinary setup, what role designers and architects can play to develop and advance tailor-made design media for more efficient products that may save lives and matters. So these concerns are somehow summarized in this book, Hybrid Intelligence in Architectural Robotic Materialization, which is also result of my PhD research, which is guided by great scholars and professors at TU Delft, and also independent committee members outside of TU Delft. And the core topics which are discussed in this book are porosity, hybridity, and assembly, with which I kind of redefine the way we can materialize using robotic fabrication, and how these differences may result in more efficient and effective building systems and material systems. So porosity is concerned with the way we can control the distribution of mass and void, and how we can translate the result of, for instance, in this case, optimization into something which is buildable, and what are the challenges of this translation, especially when it comes to robotic fabrication, and how we can innovate on the way we produce using robots. The second topic, hybridity, is concerned with multi-mode robotic production and multi-materiality, as you can see in this example, which is also a part of last year's Digital Futures workshop, in which I'm concerned with the way we compute multi-materiality, and the way, by combining multiple techniques of fabrication, we can come up with new ways of building architectural components, and how we can combine different materials, and how different material properties and behaviors can be mapped. For instance, in this example, a summary of the idea of multi-mode robotic production and multi-materiality is summarized in this chair, which is also exhibited in NAI and also presented in ETH Robotic 2018, in which we are combining multiple fabrication techniques. And the idea is to see how these different techniques inform the design, and how we can benefit from each different techniques of fabrication, and what sort of hybrid intelligence and what sort of hybrid materiality we can achieve in different resolutions. Then the next thematic topic that I'm interested in is assembly, which is concerned with the way we can grow larger than the size of the production setup that we use, and how we can sort of incorporate a material intelligence or assembly intelligence in design, and benefit from the multi-directionality, for instance, in this case, subtractive manufacturing, and how we can embed constraints and potentialities of different fabrication techniques while we are assembling. So that's why sequence in assembly is important, and how we can incorporate computational design intelligence combined with fabrication intelligence in an integrated design to production system. I would like to conclude my lecture with a series of projects that I had the chance to do in the Science of Architecture, which is a small school of architecture full of energy. And I had really the true chance to spend 4 years of my teaching and research career in this institute. And I'm sure Neil is also very much agreeing with me that it's a very small school, but with full of diversity and energy. For instance, in this project, in which we are collaborating with Audi car manufacturing company, we're combining two different disciplines of design, car design, and architecture. And it is truly fascinating to see how, within a short amount of time, we were able to design and produce a one-to-one mock-up concept car. Again, combining different disciplines, and as also Alexa kind of referred, having a kind of hands-on approach and learn by doing and making. Or in another project, which is also very much in tune with the theme of this year's Digital Futures event, material intelligence, we are looking on the way we can innovate in material design, and also combine different techniques of fabrication and tune different techniques of fabrication according to different material properties and behaviors. Or in this case, how we can map human senses, in this case, for instance, listening to a music and then translate it immediately into an art piece. With this, I would like to conclude my lecture. And I'm really also happy that Digital Futures in the past year, especially last year where we were hit by pandemic, sort of filled the gap that we were facing, the gap of not having access to the studios and labs. And I'm also very much looking forward to see how next year's Digital Futures would sort of rebrand itself, considering all the challenges that we may face in the future. And with this, I would like to thank you, all the participants, Philip, Neil, and amazing Digital Futures teams, which saw my work, and I'm truly humbled and thrilled that I received this award. Thank you very much.
Okay, congrats, Dr. Mustafini. It's a great honor to have you here, and thanks for your contribution to the community. I think you have a lot of energy, and also not only a great researcher, but you also engage into a lot of different events, actually contributes to the digital architecture. And thanks for your contribution. And next, I would like to invite Neil. I would like to introduce the next Digital Young Award, Alina. Is Neil here?
Yes. Thank you, Philip. Virginia was going to show us a little video of this astonishing project that won this award. Just to say very briefly, unfortunately, Eileen cannot be here today, but I think we were all astonished when she presented her work on Digital Futures. A really amazing project. And to say, I think maybe the whole question about interactive design really kind of becomes echoes what we're trying to do, interact with other people, with other minds, and really push forward the possibilities of how we might imagine and reimagine architecture. This was an amazing project that I think she undertook as a student at the Bartlett in the Interactive Studio under Rory Glynn. It was the winner of the Lumen Prize. The Lumen Prize being given annually each year, in this case to the Interactive Prize. And what I find so beautiful about this, apart from the technological bravado of the project itself, is the way in which it begins to really understand and incorporate the human body, and understand that the kind of, in a way, the body itself, in terms of its balance and so on, is an incredibly sophisticated apparatus. And let us not forget, while we are kind of, in a way, looking towards a future in terms of computation itself, that it is, of course, the body is completely inscribed within this world. So unfortunately, I would love Eileen to be herself, but I just want to say that this is an outstanding project. We're in the process of putting together a book in Interactive Futures with Philip Yan, Mustafini, and myself, something that is kind of continuing the tradition in the past of books about futures. And this is going to be one of the projects that's going to be featured there. But to my mind, a beautiful project and someone richly deserving an award. And it's a great honor to be able to make that award to her. Congratulations, Eileen.
Congrats to Eileen. And the next Digital Future Young Award will be Dr. Vanilla New. If my pronunciation not right, to forgive me, Dr. Vanilla No, a design and scholar, architect, artist, and finding director of Situated Computation and Design Lab at the University of Florida. Her research examines traditional and automate making cultures and practice, interdisciplinary creativity, and their intersections with society. Dr. No's work in design and computation has been supported by the Graham Foundation for Advanced Studies in the Fine Arts, the Mozilla Foundation, and the Ideals to Innovation, among others. Her TED Talk is titled The Power of Making, Craft, Competition, and Carnival. Dr. Knowles holds the PhD from University, a Master of Science from MIT. a bachelor of architecture from Harvard University, and a diploma in civil engineering from Trinidad and Tobago. She has been a researcher and educator at Georgia Tech, Penn State, and the Singapore University of Technology and Design, and MIT, and has practiced as an architect in the US, India, and Trinidad and Tobago. Please join me to congrats Vanilla No on her award, and welcome her to sharing a brief presentation with us about her work. So the floor is yours, and please.
First of all, thank you so much, Philip, for that lovely introduction. Thank you so much, Neil, and thanks to the entire Digital Futures Organizing Committee. I greatly appreciate this. Okay, I'm honored and humbled. Thank you very much. Without further ado, let me share my screen. Please let me know if you could see this. Yeah.
Yes, please.
Okay, good. Okay. So again, thank you so much for this honor. I'm grateful to be here today, and congratulations to all the other winners. Okay. So as mentioned in my work, I examine traditional making practices and cultures, digital and automated practices and cultures, and their intersections with society. This includes building new computational and digital tools, new methodologies, developing new practices and research frameworks, and building new expressions in architecture and design so that we might explore new reconfigurations of computational design practice, pedagogy, and our publics. Some of the problems I'm addressing in my work are the disappearance of craft skills, knowledges, practices, and communities, the omission of craft skills, knowledges, and communities from pedagogy, practice, and discourses in computation and computing, and our understanding of the effects of automation alongside human welfare, because technologies usually impact society's least privileged. The vision of my work is to repair craft practices and to repair computational design practices. And when I talk about repair, I use Sennett's description as a point of departure, comprising restoration, remediation, and reconfiguration. Restoration as a recovery in which the damage and use of history is undone, with the restorer as a sort of servant of the past, remediation as preserving an existing form while substituting old parts for new and improved ones, and reconfiguration as a radical kind of repair, one that is more experimental, exploring connections between small repairs and their larger consequences. And I go about this repairing of craft and computational design practices through a framework I call situated computations. Situated computations is an approach to computational design that grounds our technologies or methods or theories in the social world by acknowledging the historical, cultural, and material contexts of design and making. It responds to a setting's social and technological infrastructure, and it asks that we refuse to remain ignorant of social and political structures that shape them. Currently, there are 8 principles for this framework for how we design and develop our tools or methodologies or theories, etc., such that we reveal histories, human dimensions, as Neil just mentioned through that previous winner, and recognize the partiality of our knowledges within specific contexts. Some of the things this situated computations approach accomplishes is that it creates a space for participation by those who are currently missing. There are always people missing. It resists the segregation and privileging of certain types of intelligences and skills, and it seeks to amplify the stories of historically excluded and marginalized groups and knowledges. So I'll now show you how this approach is operationalized in my work. I'll start here in the cultural design practice of the Trinidad Carnival, in which the craft of wire bending is embedded. So French planters introduced carnival to Trinidad in the 1780s, but after slavery was abolished in 1834, formerly enslaved Africans reinvented the carnival to express their creativity, their freedom, their aesthetic sensibilities, and claim their humanity in the face of a system that considered them less than human. And wire bending came out of this practice, this cultural design event in the 1930s. It was described as one of the most highly developed crafts coming out of the carnival. And in it, wire, fiberglass rods, and other linear rod materials are bent and shaped to create costuming and large dancing sculptures, as shown here in this slide. In my ethnographic work, to gain an understanding of the carnival's culture, its traditions, its people, its social and political context, I discovered that the craft was dying. And some of the reasons for this were little to no documentation of these knowledges, slow transmission of it, dying practitioners, and changing practices in light of technological developments. One step to addressing this problem of dying knowledge and a dying craft involved developing what I call the Bailey-Derrick grammar, named after two expert wirebenders I studied and observed, Albert Bailey and Stephen Derrick. This grammar computationally describes the technical knowledge in wirebending. It's a series of drawings that describe the materials, steps, and techniques in wirebending, allowing analysis, transmission of expertise for education and practice. It also facilitates documentation and recording of the design and making process and sheds light on the computational dimensions of the craft, opening it up for expansion and inquiry. It's in a medium that's familiar to that community, drawing with pens, pencils, etc., not requiring necessarily highly expensive technological infrastructure. After developing the grammar, I had to find out what happens when it's deployed in education and practice. And so I taught the technical knowledge, the theory, if we want to call it that, behind the craft, and tested it with students and teachers in Trinidad and Tobago to repatriate this knowledge and observe what would happen. I also conducted field studies, design workshops elsewhere. And these are some of the images of work before engaging with the grammar and after. After learning the grammar, craft skills improved, replication of artifacts was possible. Participants mentioned feeling more confident about what they might explore in this craft. But one of the coolest things I think to come out of it was a new collaborative approach to this craft. Currently, the craft is one-to-one with one person making one artifact. What the grammar afforded was collaboration with participants being able to engage in different roles. So one could document, they could analyze, they could assemble, they could fabricate, some of the many roles that they could now engage in with multiple people working together on one or more artifacts. I also developed computational design approaches or additional computational design approaches that included CNC wire bending, digital design software, digital fabrication machines, etc., to again further open up the practice to those who might be interested in engaging using digital tools and techniques in this practice. And the practice is labor intensive, so to attempt to address that also. These are images of some artifacts designed and created by students using these new computational approaches. And these investigations also included creating new systems and methods for designing and fabricating dancing sculptures for the carnival, creating new possibilities also for architectural form and structures, building on traditional costuming, movement in the carnival, and its craft practices. This also led to new tectonics. Because of the symbolic computational descriptions of wire bending via the Bailey-Derrick grammar, we could now test and design new matrices, new types of connections for applications at the architectural scale. Here are a few examples of some of the tectonics that we designed and tested and explored to make a pavilion. This is an image of a pavilion that we made using these wire bending techniques and tectonics. In a second pavilion that we built, we pulled from, again, the craft of wire bending and costuming in Carnival. On the left, some costumes from 1984 by Peter Minshall. These are active bending structures using fiberglass rods and textiles. And pulling from that, we wanted to use the behavior and stresses of fiberglass rods in making a pavilion for a lightweight competition. This is an image of our prototype. And here we are exhibiting our pavilion at IASS in Spain in 2019. So in sum, my work seeks to repair skills, knowledges, tools, communities, and expressions in both craft and computation via situated computations, which seek to create space for those missing, resist the privileging of certain intelligences and skills, and amplify the stories of historically excluded groups. And with that, I want to thank everyone. Congratulations again to all the winners, and thank you for this opportunity.
Congrats. Thanks a lot to Anita, and very interesting situated computational design, and you integrated the very interesting special methodology which bridge the culture and the digital technology. I think super impressive. Congrats. And the final recipient of Digital Future Young Award today, this year, goes to Mr. Ma Zhao. Ma Zhao is an architect, designer, and a computer scientist. Based in Zurich, Switzerland, he is a researcher at ETH Zurich, where he focuses on optimization-based methodologies for computational robotic fabrication. His featured work, styled robotic sculpting, developed a novel design and robotic fabrication system for carving clay sculptures with robotics. Now received a master's degree from MIT and focused on the engineering structure research, and he obtained his PhD at ETH, where he conducted cross-discipline research, shared with Funicular research, computational.
我没有听明白你的意思，请再说一。
And he actually from the Funicular research team, and also the computational robotic lab from NCCR. And also he is one of the senior researcher in Disney Research Zurich. Zhao seeks to bridge the fields of design, engineering, and computational fabrication through cross-discipline collaborations. His work has featured in various awards and patents across the discipline, including architecture, landscape, and computational design. Let us welcome Zhao and Ma Zhao to give us a more detailed and in-depth look of his research and works. Let's welcome Ma Zhao, and the floor is yours.
Okay, thank you, Professor Yang. And good morning, good afternoon, good evening. I'd like to thank the Digital Future Committee for offering this award. I'm very honored and grateful to be here to join the ceremony. Yes, I'm based currently at ETH in Zurich and have spent the last 4 years here. So as a non-Swiss, it's a very special experience here, since the school, on the one side is enjoy this sensational Swiss scenery. It's very beautiful. But on the other side is focusing on very hardcore engineering problems and technologies, and trying to solve very practical engineer questions through hands-on research. And this is also why I'm here, that I'd like to share with you some of my thoughts and research in a little in-depth way the next 10 minutes on the application of computational systems in applying computational system in the design fabrication field. So we've all seen images like this over the media. Automated robots dominating the manufacturing industries. However, it is not until recently that the left-behind construction industries advances from labor-intense construction to digital fabrication technologies, using materials ranging from timber, concrete, carbon fiber, and metal sheets. These projects pose special challenges for using robots in the architectural construction field. The need for adaptive fabrication process to suit for the individual unique components, the processing of complex and general geometries, and the incorporation of fabrication-related constraints. Examining closely, we can classify these constraints into the ones that are directly related to fabrication processes. For instance, the path planning for the robots, the slicing of the geometry for 3D printing, the precision of the constructed model, and the assembly sequence of the parts. And the ones that are not directly associated to fabrication process, but will affect the final results. For instance, whether the object can stand on the run, will the material deform or decay? Are the forms structurally efficient, or how do the designers want the object to look like or behave? For different projects, we evaluate at which stage does these constraints take effect, and how much can they be decoupled and managed independently. For instance, the spatial timber projects, the assembly deviation, the element deviation during the fabrication stage is coupled with the assembly sequence. But the robot trajectory can be managed afterwards. As these constraints take effect after design is finalized, we place the project here in our system. Similarly, for the different project, the funicular floor system requires a stable and highly structurally efficient form. The shape of the ribs is also modified for casting as a specified design preferences. And these constraints are highly coupled and need to be resolved during the design stage. Those are placed on the upper left corner. So after evaluating many projects, we discovered that many non-robotic fabrication projects has already used optimization approaches to manage coupling constraints, while the existing robotic fabrication projects manage fabrication constraints that are mostly decoupled. Which means that after almost 15 years stepping into the digital age of architectural fabrication, the area of managing coupling constraints in robotic fabrication is still not often addressed, especially when the target objects are individually unique or geometrically complex. And this, I believe, is the next step of architectural robotic fabrication. It is thus the aim of my research to investigate optimization-based approaches that integrate geometry processing and motion path planning with coupling constraints for robotic fabrication in our fields. Since this is not a very common topic in the design field, please allow me to explain it briefly. Look at this image. It is not very hard to compute the robot trajectory to throw the ball into the bucket. But it is not easy to let the ball stay inside after several bounds. Instead of trying many times ourselves, we can tell the computer several things. How does the robot throw? How does the ball fly and bounce? And how does the bucket limit the ball's movement? After that, we can then ask the computer to run it thousands of times until we get the desired result. This brings out the 4 key steps of using optimization-based approaches for design and fabrication tasks. Modeling of the material and fabrication process, the abstracting the constraint and design parameters, formulating the optimization problem, and finding the target robot motion by resolving the problems. These steps require both physical experiments and computational implementation in different magnitude. I will next demonstrate how they are conducted in the project stylized clay sculpting. The goal of this project is to develop a framework that addresses coupling constraints in the fabrication stage, but also investigate how optimization can help with the design. We pick the clay material as it enjoys a wider application across different scales from crafts to architecture. We also noticed that the robotic milling has already been widely used for the manufacturing of hard materials very precisely, but it is usually not possible to mill soft, water-based clay. So, is it possible to combine the precision of the machine with the flexibility of human hand to create clay artifacts with finer details? Additionally, is it possible to embed the user's design intention directly into the fabrication process? What these two questions are actually asking is to use a robot as our hand and command it by our own mind. This is the overview of the project. The whole design to fabrication pipeline works as follows. From an input mesh, I first decompose the whole model into several patches and generate 2 paths for each of them. I then use the path planning framework to generate robot trajectories, which can be executed by our robot on the physical model per patch. The whole pipeline follows a divide and conquer approaches so that the user have more freedom to design sculpting styles for the local sub-areas. And to allow this, I developed a graphic user interface, embedding all the design factors that are extracted from a set of physical experiments. These factors are all embedded into this graphic user interface, which provide the user with an intuitive, interactive environment for the decomposition process. The user can freely draw scribbles on the mesh surface with the mouse, and the software will decompose the mesh in the background based on the strokes. The user can further draw additional strokes to modify the patches and change the overlap areas. After the decomposition, the tool paths are generated on a patch level, and each patch contains a set of trajectory points defining the tool positions and orientations. We've also examined the painting styles from famous paintings and extracted different brush strokes as additional design factors and transferred them into the 3D object we fabricated through our systems. The optimization will then figure out the path planning problem. We describe each robot pose by a set of joint angles and optimize for the best cut between the original shape and the target shape. We formulate an unconstrained optimization problem to optimize for the robot trajectories. The primary objective evaluates the distance between the tool path and its target. The constraint objective resolves collisions, limitation of the joint angles, etc. And all the secondary objectives are mainly defined to help with the quality and practicability of the tool path. Here's a video of showing how the optimization takes initial shape, generate patches and tool path as input, and sequentially run over each patch to find the robot trajectories. We run the optimization for each patch individually and store the results separately to allow independent fabrication of different sub-areas of the model. This eye demo demonstrates the success of sculpting the highly curved iris areas, which cannot be achieved without optimization method. Especially, I only need to provide a very simple toolpath as input, and the system will figure out all the dirty work. The second example in the face, that we use this example to demonstrate the power of the design tool to create different sculpting styles. And these are the physical, These are the physical elements we fabricated afterwards. And these are some additional results that featuring the painting styles we extracted from famous paintings. So while this object hasn't touched the application in the architecture domain, I believe the computational system could be easily adapted to other applications. For instance, the sculpting surface of a large-scale architecture components using the system's detailing ability, or replacing some of the molding materials since clay is very cheap and sustainable. So besides the three key challenges I proposed at the beginning, the supporting of the design process, together with the other three challenges that we're facing, will further shape the field in the next stage. And it is the role of our generation to define it, solve it, and realize it. Last, I'd like to end my presentation with a quote that Steve Jobs once said in the 2011 Apple product announcement. The technology alone is not enough. It is technology married with the liberal arts, married with humanities, that yields us the result that makes our heart sing. That's it for the presentation. I hope you like it.
Thank you. Thanks a lot to Ma Zhao, and congrats to the four young award. And it's great. Congratulations to all you guys. I think it's great opportunity to have the young generation here, because you will play more and more important roles in the community. Actually, like Ma Zhao, it's very interesting for your introduce the artistic making process to the collaboration between the human and the robotics. Actually, it's artificial intelligence, maybe the neural formation process could be very interesting, embedded into the adaptive process of robotic crafts. So as very important and very a lot of collaboration potential possibilities for your research to the future. So congrats to the four young award recipients. It's a great honor to be here to announce your awards. Today, I think last but not least, and also the most important, is the Matthias Riepmann Memorial Award. It's a great honor for me to announce Matthias Riepmann Memorial Award. Dr. Matthias Riepmann was a senior scientist at the Brock Research Group of Institute of Technology in Architecture at ETH, where he coordinated collaborative research project, supervised the development of demonstrator, and established and deepened the multidiscipline partners with industry and external research groups. He was a project manager of numerous key BRG projects and demonstrates has more than 10 years of research and teaching experience in the field of digital methods in architecture. And the Matthias Riepmann Memorial Award is given the most outstanding achievements each year in the field, which Matthias had devoted his heart and soul to this year. And I think Matthias have a long-term friendship with us over the past 8 years. We met each other every year before 2018. And he actually set up the famous plugin in Rhino Vault. I think he is one of the key senior researcher in Philip Bloch's research team. And he's very modest and also a great programmer. I think he contributes a lot in this community, and to showing this award, to him. And this year, I think it's a great honor. The award is presented to Sigrid Adrianson's. Sigrid Adrianson's research interest lies in the mechanical structure surfaces and the static and dynamic loading advance of the shape generation approaches based on analytical formulations, and also including the numerical form finding, and also include the fruits and machine learning techniques. This research has focused on optimization of design and behavior of membranes, shells, and both continuous and lattice, subjected to the earthquake, the storm surge, and environmental. Recently, robotic construction constraints In 2021, she was named the Fellow of Structural Engineering Institute of the American Society of Civil Engineers and received the 2018 ACSE George Win Award. Today, she co-chairs ASCE and Aesthetics in Design Concrete Shell Roofs Working Group, International Association of Shell and Spatial Structures. She directs the Form Finding Lab at Princeton University and teaches classes on nonlinear mechanics of solids and slender structures, structure design and integration of engineering and the arts. So congrats to Sigrid for the award. Please welcome Sigrid to accept the award and give us a comprehensive look at her work. Welcome, Sigrid. We can see the screen, but we cannot hear you. Maybe you got mute.
Okay, good morning or good evening. Can you hear and see my screen now?
Yes.
Okay, perfect. Well, first of all, I would like to thank the Digital Futures Committee for electing me for this very important and prestigious award. I also congratulate all the other winners of the different awards. I would like to first bring up the memory of Matthias Riepmann. As Philip already said, he was a great inner group at ETH, and I had the pleasure of meeting Matthias at different occasions. One of them actually was when I was working with his mentor, Philip Block, on the book that you see on the right-hand side. Matthias passed away in 2019, and he is still greatly missed by many of us. I'm going to present some of the work that me and my research group do at Princeton University, and I'm mostly going to present the work on shell structures. And I'm going to start actually with the project that you see on this picture on the right-hand side. So this picture here is the elevation of a masonry building in Amsterdam. It's actually a 17th century building that was constructed to store gunpowder. And since the 17th century, it has served as a prison, and currently it's a museum with an inner courtyard. And this museum features models that kind of showcase the history of the Dutch as a seafaring nation. Now, this is a plan of the same building. Actually, as you can see, it's well, it's one building, but it consists of 4 parts that are arranged in a square. And in the middle of the building, you see an open courtyard. And so now I'm going back to 2003, 2004. A limited design competition was written out to propose a new roof to cover this courtyard, so that this courtyard could be used for ticketing and for events. And so we were invited. At that time, I was working in industry for Nain Partners, and we were invited to participate. Now, inside the museum, you find many, as I mentioned, many artifacts, such as scale model boats, but also you find maps, because the Dutch at that time were very advanced in the making of cards, of maps, cartography. And what you see here is the 16th century map of what they thought the world looked like. Some of it they got quite right, but some of it is not so right. But besides kind of recognizing the Earth on this, or the different continents on this, you also see that there's a geometric pattern positioned on this map. And this geometric pattern actually 16 windroses. So basically all these lines that you see were lines that the winds were blowing and that they thought that they could actually sail along, a little bit like a GPS system. So we thought this was an interesting system or an interesting geometric pattern that we would like to incorporate in the roof. Because we can impose a square on it. You know, this is kind of the size of the inner courtyard. And if we could transpose this pattern into a roof, that would be very exciting. So basically, the roof in plan would look like this. Now, as you all know, this courtyard is, has substantial dimensions. It's in the order of 90 feet. That is about 30 meters by 30 meters. It's not quite a rectangle, but let's assume this is a rectangle. As you know, you cannot actually span such a large distance with a straight kind of grid of beams. So we thought about how can we make this into a very shallow cupola, and it had to be very shallow because we're working in a historic context, and the new roof could actually not be seen above the existing building. And so this is work done in 2006. Actually, so we used algorithms that I developed in my PhD for the form finding of grid shell systems or bending active systems. These algorithms were later incorporated in Kangaroo, in Grasshopper. So at the top, you see here the grid as we took it from the map. And at the bottom, you see the curved funicular shape that it develops into when we use a hanging chain model. Now, there were quite a lot of restrictions on this. I already mentioned the height, so we could only have a limited height of the cupola, of the grid shell. But other limitations was that we could not put any horizontal forces on the edges, because these had to be taken by the masonry walls. And although they were very heavy, very thick masonry walls, they were not designed to take this horizontal thrust. So another challenge was that all the facets that we see in this grid shell could not be, are not triangulated. And as you all very well know, 3 points define a plane, but from the moment that you have 4 points, and we have some facets with 4 or 5 points, they don't necessarily lie in a plane. So we also work together with Chris Williams from Bath University to solve that problem. Okay, so fast forward a couple of years, we won the competition, and here you see the roof constructed. It's a very successful design. It won a number of awards, but I think the most successful measure is that actually people go and sit under this roof to eat their lunch. So when it's lunchtime, the offices around it, the people, when they have lunchtime, they actually go into this cupola and sit underneath this cupola. And so basically it means that we've created here a public space that is enjoyed by people. People just come and sit there. We also inserted at the nodes different LED lights to create the impression of an evening sky. And this hopefully reminds us of the history of the Dutch and their seafaring history, where they go out on their boats and are guided by the winds and the stars. So this is, of course, a slightly older project. As I mentioned, it's from 2006. But when I was working on this project, I realized that these curved surfaces, whether they're continuous or whether they are lattice structures, they offer many opportunities. First of all, they're indeterminate structures. That means that if somehow a member gets broken, if one of those steel rods gets broken, then the flow of forces will find a path through all the other members. And this is very good for, we call it basically resilience, right? So if some of the members break in this system, the whole system will not collapse. Secondly, these members, as you can see, are very, very shallow, and that is because we've got shell or membrane behavior. That means that under permanent loading, all these members are actually loaded. There is no bending in them. And then finally, also the amazing thing is that this is very stiff. These kind of systems are very stiff because of their form, not because there's a lot of material there, but because of their curvature. They achieve a lot of stiffness, and that is very good for example, roofs or bridges where you don't really want your roof or your bridge to deform too much. So, so I really fell in love with shells and membranes because they have all these wonderful properties. They're very lightweight. That means that they don't really cost a lot to the environment, and they therefore also have usually have very low economic cost. Diving into this a little bit further, there's anecdotal evidence that a lot of realized shells are very resilient in earthquake, tornadoes, and hurricanes. And these are just some images pulled from the internet, from different parts of the world. We have shells, I'm looking here, bottom left, surviving tornadoes, top middle, surviving tsunamis, earthquakes on the right-hand side of San Francisco. So there is something about shells and membranes that makes them very resilient to very high or extreme loading. And so we wanted to investigate what this was. As an example, we took the Felix Candela Church in Mexico City, and which survived a very strong earthquake in 1985, while as all the other buildings around it collapsed. So we modeled this shell, or we modeled a couple of bays of this shell in a finite element analysis, and we carried out a dynamic analysis to find out why do these shells, when they're shaken, when so much loading is put upon them, why do they stand up or why don't they break? And so, for example, for this particular shell, as I mentioned, we carried out analysis and we found that their eigenfrequencies are very high. For this particular system, it is 3 Hertz. The eigenfrequency means the frequency or the fundamental frequency at which it wants to start shaking. And what we see is that the frequency of the earthquake is actually much lower. It is in the order of 0.5. So these two frequencies are very far apart, and that means that you don't get resonance. Resonance means that when the eigenfrequency and the frequency of, for example, the earthquake are kind of coinciding, and this is what happened with the Millennium Bridge, then you get very large excitations in your structure and you get very high damage. So this will not occur with shells because, and you might not all like formulas, but on the left-hand side, we have here the formula for frequency, and it's a function of K, which is the stiffness of the system, and M mass. We know these are very lightweight systems, so M is very small, and because they are curved, they have very high geometric stiffness, so K is very high, so therefore they have very high natural frequencies or eigenfrequencies, and this is very unusual. Usually for structures, the frequencies are much, much lower, but because these structures are so stiff, they have very high eigenfrequencies. So then we were interested in finding out how can we find arches and shells that are form-found. So basically they're going to exhibit membrane behavior when you have, for example, earthquake loading. And we all are very happy with the rebirth of graphic statics, which allows us to draw the forces, or the forces here, these are the external forces, and from that deduct the internal truss line. But this has been traditionally been done for gravity loading, because that's the most important loading in shells or in domes. But what happens if we impose also horizontal loading due to the earthquake on it? And that's what you see here in green. So if we start combining self-weight and earthquake loading, we end up with these funny shapes. So for example, using graphic statics, for example, you see this green line here, that would be the truss line in an arch under self-weight and earthquake loading. Of course, the earthquake can come from one side or it can come from the other side. So we have to take both truss lines, you see the green one and the red one. And then if we take the envelope of that, we end up with, a shape like shown here. I'm looking now at the bottom left figure. We see this shape of this arch. Now, this is a funny looking arch, but of course, as we all know, with 3D printing, these kind of arches are going to be possible. We then carried out a verification to see whether indeed these kind of arches are much stronger than the traditional arch. And we used virtual work to do that. And we see indeed that, this shaped arch can actually take, combined self-weight and earthquake loading before it starts collapsing through a 4-hinge mechanism. So this is very interesting. This is an arch, but what if we want to do a shell? Well, we can actually do the same thing. So if we generate a funicular polygon, what you see top left for earthquake and gravity loading, we mirror image it, but instead of now taking the envelope, we offset it, and then we repeat that a couple of times, and we loft a surface through that, we end up with a corrugated shell that in theory should be very good under earthquake loading. And so that's exactly what we did. We evaluated this using a nonlinear pushover analysis. Now you might say, well, these kind of structures on the right-hand side, you see we 3D printed one. You might say, well, I've never seen anything like this, but actually in 1978, Eladio Dieste built a similar shell. This one is made out of very thin bricks. So corrugated shells have been built, but these two shells are slightly different. On the left-hand side, you see that the corrugations are all parallel, whereas in the right-hand side, which is our figure, they are slightly off-centered, and this causes different curvatures within the surface. So, of course, we can do parametric studies because there's a number of things that we can vary. We can vary the corrugation depth as well as the amplitude. And you see here, bottom right figure, the Dieste figure. So this is the shell that we just saw. So this is our base model. This is what we're going to compare all our variations with. So here we generated 5 different variations. The variations vary either in depth of the shell. So for example, FF1 and FF3 have very deep inundations, or and also the other thing that we can do is the amplitude. So how many waves we get, for example, meter. And we see, for example, that FF2 is, has a lot of waves, in contrast, for example, with FF5, which has very low amplitude. So as I said, we carried out a nonlinear pushover analysis. So basically that's an analysis that puts horizontal loads and keep on pushing. This is a concrete shell. All these shells have the same amount of material. So we're comparing likes with like. And with this nonlinear pushover analysis, we can see how this thing starts cracking until eventually it fails under, again, the 4-hinge mechanism. So what you see underneath all the figures, so you see an elevation, you see a perspective, an elevation, and at the bottom of each figure, you see a finite element snapshot showing the 4 cracked zones. So we get 4 hinges occurring just like with the arch. But what is different is the location where these hinges occur. So they always occur at A and E, and then either at D or B, and sometimes at C, but there's always 4. And there seems to be some kind of pattern in this. The sequence and the location of these hinges really depends on the geometry. It means on the depth and the period of the corrugation. So for example, in FF2 and in FF4, we see that we get indeed 4 hinges, but one of them is at the crown. And what we notice here, both FF2 and FF4 have very small width, or have very small depth of the shell, right? At the base is very small. Whereas all the other ones where we have a much deeper depth and also a much longer wavelength, we see that we actually don't get a hinge occurring at the crown, but it occurs at one of the quarter points. So, okay, so these shells all behave slightly differently. And actually, let me just see. Oh, yeah. How can we explain this? Basically, the hinges will occur at places where we have single curvature. So remember how we made this surface. There's a lot of double curvature and single curvature locally in it. And basically the places where we have single curvature, those are the places that are the least stiff. So when we start applying our load, those are the places that are going to deform, the single curved ones, to deform the most and therefore crack first. And that explains why in some places we have hinges occurring at the top and sometimes hinges occurring at the bottom. So if we compare the different numbers here or different shells here for their capacity, again, the first one is the Dieste shell. So that one's, the first crack will start occurring at a peak ground acceleration of 0.2, and it will crack or completely collapse at a peak ground acceleration of a little bit less than 0.3. And what you immediately see is that all the other variations that we propose, same span, same dimensions, same amount of material, we see that all of them already outperform the Dieste shell, and actually in particular the FF3 one. So this is the one that has quite deep depth and has very small amplitude. That one actually performs much better. The first crack starts occurring at 0.4 GPa, and then it kind of collapses at 0.5 GPa. That's like a huge earthquake. But what we see here, and this is really what really surprised me, is that using the same amount of material, we can totally tailor the behavior of these surfaces by introducing corrugations. And this is almost like metamaterials, where we are going to, by using folds or by using openings, we are going to really program how the shell is behaving. And I think this is very exciting. Oh, excuse me. Going back, so this is a rendering of what such a shell would, for example, look in San Francisco, which is very much an earthquake-prone zone. But of course, you know, all of you know that the construction of shells is very expensive because of the shoring and the formwork that is involved, and that is actually been named as one of the #1 obstacles in the adoption of shells and surface structures is the formwork, because basically you're building two structures. One structure is the formwork, and then the second one is the shell. And then once that's done, you have to out, and there has been efforts in recycling and repeatability. But wouldn't it be wonderful if we could build shells without any formwork? And actually, going back way into history, shells have been built, as you know, for a long, long time. And one of the most amazing one is the dome of the Santa Maria del Fiore. It was built by Filippo Brunelleschi, who was actually a clock and a jewelry designer. And you know, he spent many years building this dome. This dome was supposedly built without scaffolding. And that is, of course, really amazing. This rumor, or you know, this knowledge has been passed down. But unfortunately, Brunelleschi never really wrote down how that would have been possible. And there have been many speculations as to how this very large spanning dome could have been built without scaffolding. But it has actually never been shown how this was done. What we do have is drawings. And actually, Brunelleschi, he worked with the Masonry Guild, and particularly with one family, the Sangallo family. And what you see here on the left-hand side are drawings of Italian Renaissance domes. What do you see? Well, first of all, bottom right, you see a cross section. You see it's actually a double layered dome. So you have the inner dome, which is first constructed, and which has some bricks sticking out, which are the yellow ones. And then the second dome is imposed upon that. If we look from the top left, we see a drawing of the pattern. We see the spiraling pattern occurring in these Renaissance domes. And some people might say, well, this is purely decorative. But actually we started, so this is a drawing of the inner dome. We started thinking that maybe these vertical bricks that make this spiraling pattern might have a structural function and might maybe give us a clue as to why or how you could construct domes without any scaffolding. And so on the right-hand side, you see a rendering of the dome that we started investigating. This work was done with the University of Bergamo in Italy. And what we see here, so we started reconstructing one of these domes, brick per brick. And there's a few things that are important for a self-centering system to be able to occur. First of all of these domes, we assume that the layers were laid layer per layer. So this was not built in ladders. This was built layer, closed, and then the next one a little bit like an igloo. The other one that we also assume is that the domes are leaning inwards. And so we started exploring how can these here gray colored bricks, how can they make sure that this dome doesn't collapse inwards? Well, so you have on the one hand the horizontal bricks, which are colored here in white. They are in closed layers, and in that you have the gray upstand bricks. And so what we found, and I'm going to close in here, these upstand bricks are actually very important. They are a little bit inclined inwards, and when you put the next layer of horizontal bricks in there, they will actually slide in until they jam against the vertical upstand bricks. And so once they are jammed in, they cannot actually slide inwards anymore. So in the lower layers of the dome is just built like a vertical wall, right? It's just counting on like actual gravity loading. But from the moment that it starts curving inwards, when you put the horizontal bricks, they tend to slide inwards and then they get jammed against the upward bricks. And then they cannot slide any further. The horizontal bricks then exert a large force on the vertical bricks, and the vertical bricks are fixed in the layer below and transfer the loads to the layer below. And so basically this is called a plate bond system. What you see here on the right-hand side, so we modeled, we did discrete element modeling of all the bricks. There's more like 10,000 bricks, layer per layer construction sequence. What we see here is a still from that analysis. On the top, we see what happens when you have bricks being positioned and your friction angle is 0. This is, of course, never the case because you have your mortar there and you have your bricks against bricks. But from the moment that your friction angle is about 10 degrees, your bricks get kind of stuck and you don't really need any scaffolding, right? Because it's the upstand vertical bricks that will refrain the horizontal bricks from sliding inwards. So this we published this, and this work really got a lot of attention. It was published in the Smithsonian, in the Times, in La Repubblica in Italy, because it really showed scientifically for the first time how these Renaissance domes could have been built without any scaffolding or formwork. And of course, I am very interested in construction practicing from the past, but I'm actually more interested to learn how can we leverage those for construction today and for construction of the future. And so I'm very interested in looking at how we can integrate form finding and robotic construction technologies to reduce construction waste, but also to make safer working environments, and as well as increase productivity in the construction industry, because the construction industry is one of the industries that is lagging most in digitalization and robotic adaptation. So I had the great fortune of working with the Create Lab at Princeton University and with SOM, a superb architectural and engineering practice in the US and worldwide, on the construction of a pavilion, a glass brick pavilion that would be constructed by 2 collaborative robots, which would be constructed without any formwork. So we were also realizing on this herringbone pattern, I forgot to mention the spiraling pattern, the herringbone pattern. We used that pattern to construct the arch and then finally build out a pavilion without any scaffolding, but with 2 robots working together with humans. And I'm going to show a video now that was, it's only 2 minutes, which was made by SOM to show this innovation. I hope it's going to work. Yes, and I'll switch off the sound. Okay. Oh, oops. Hold on. No. Stop share. Mhm. Okay, I think I'm back on mute. So that brings me to the end of my presentation. I really think that the construction industry needs to catch up with other industries. We're really lagging behind on digitization and robotics. And I think these new technologies combined with very exciting new mechanics and form-finding techniques, optimization techniques, artificial intelligence are really going to make a huge, or have the ability to make a huge leap in structural design, but also in architecture. And I believe that these technologies combined with all these, very exciting approaches that we are developing will allow us to not only construct the way that we already know, but construct in new ways and allow for new structural typologies, new structural language, and new architectural language to emerge. So thank you very much for nominating me and electing me for this award. I am very honored. And I would like to thank the Digital Futures platform to create also a platform in which we can all showcase our work. Thank you.
Great. And thanks a lot. And congrats to Sigrid for your phenomenal lecture. I think it's really good, and it's really interesting to create in the future by learning from past, as what you're saying. Actually, graphic statics is a very, very interesting design methodology which can integrate not only the structure design, but also we can introduce this kind of structure logic to the architecture design process. And the last, your introduction about the project, actually you introduced the robotic construction process to actually doing this kind of scaffolding and double curvature shell surface. I think it's great to create a lot of new potential possibility based on the graphic statics formation process. It's really interesting, this formation double layer shell structure formwork as a kind of scaffolding to support the real double curvature surface. It's a kind of intelligence. The topic of this year is material intelligence for CDRF conference in digital futures. I think your lecture actually gives us a very interesting, I think it's a comments to the material intelligence, which based on the initial logic of how the forces is flowing inside the structure. And this kind of formation is interesting based on the formwork, based on the saving the energy saving the scaffoldings as part of the structure, and which will very interesting about our workshop. Actually in Shanghai, I collaborate teaching with Philip Rock team, and we're making a bridge. Actually the scaffolding is part of formwork, and which is a composite structure system. But I think saving the material of scaffolding is kind of the beauty, is kind of transformation to the material intelligence beauty. So thanks a lot for your great lecture, and your research really meaningful and really interesting. And thank you so much for Sigrid. And also we want to congrats to all the award winner today, this year. And we're looking forward, next year will be more interesting. Actually, I want to introduce, we have a nominate rules. We have academic committee, including more than 60 expertise researchers and the practitioners, and gave nomination process to the committee. And this year we added the fellowship of Digital Futures. who are Maxia and Philip Brock, Maxia Archimangus, and we have 2 female voices. One is Matter Thompson and RIT Marco Polo. I think it's great to have the future the fellows inside the future team who will help us to make the world final decision and options in the future, and also give us a lot of support in our CDF conference and publications, help us to organize and also make promotion. The Digital Future research team go to more academic level. So it's a great time for us to make the closing remarks between you and me. I want to say something first, and then you will have some closing remarks. I think it's a very interesting experience, because at the very beginning, we're the volunteer 10 years ago to organize these special events and to contribute to our dream, which is based on the collaboration between the human being and also machine intelligence. So right now, I think Digital Future community is growing super fast, and also based on the volunteers who are here, including a lot of young researchers, PhD candidates, and also some young professors, assistant professors from all over the world help us to organize this really special event. And I think it's a totally interesting bottom-up process. We have different hubs, and in the next year, we try to organize the events more reasonable and more logically by the Digital Future hubs. We will have coordinator in different hubs to help us to organize the workshops better. And the weekly New Reach is organized Digital Future talks. I hope that will be still going on weekly or monthly. We will invite different expertise from different research topics to give keynote speech and Digital Future talks on this platform. I think it's a kind of exchange knowledge and also learning from each other and make a lot of debate, discussions, and exchange of ideas on this platform. At the same time, we want to help the young researchers to publish their thesis or their papers on the artificial intelligence future coming publication platform. So Digital Futures is I think open education platform, and we're looking forward to make it more influential and help small generation growing up like me 10 years ago. I think it's, although 10 years passed, not only my research but also my practice, we're learning a lot from a lot of expertise who make lectures and teach workshops on this platform. So hopefully, and looking forward, and more young researchers or expertise or the students coming to join us and make a more social impact and a phenomenal future in Digital Futures. So thanks a lot for that. So I would like to invite New Reach to add some closing remarks, please.
Thanks, Philip. Thank you. First of all, yes, we're continuing. I mean, next week we have the exhibition opening online, and after that, I mean, we want to take the opportunity every single Saturday to keep this debate alive and to keep this whole thing going. We've only just started. So let me just say one small thing. I think Philip mentioned one thing. He said learning from each other, and I think that is really the important thing here. It's not. We shouldn't be learning from Las Vegas. We should be learning from each other. And I think this kind of swarm intelligence that we're developing, I think is really something very special. Coming together on a single platform, the kind of exchange of ideas, this thinking together, I almost see it as a kind of global brain in operation, is really been quite a wonderful development. And I just want to also pick up on a comment that was made by Alexandra, which I mentioned before, I think. webs woven by other minds. I want to just change that slightly. I want to say, first of all, webs woven with other minds. I think this should be seen as kind of like a collective form of intelligence where we're all contributing to this whole thing. And I also want to maybe change the tense, not from webs woven in the past, but webs being woven and being woven in the future. I mean, I think the key thing about the one concept that that Philip and I've always put forward is the name the future. But I want to stress this notion of the webs starts with the letters W-E, we, and really I can't overemphasize the fact that this is really a collective operation. This is something that it's not about Philip and myself, it's about a team, a whole team. We might have initiated it, but it's a collective organization, which is really astonishing in the way in which so many different people from so many different parts of the world have contributed to this whole kind of this whole project, and a project that I think hopefully is going to have a huge impact on the future of education. And we've just begun, and I'm sure it's going to have a huge impact in the future. So I wanted to say that it's kind of like it's not about any one of us, it's a team effort, and it's been and what I find so rewarding and refreshing has been this incredible commitment by the team to do this selflessly on behalf of everyone else, not being paid, doing it because of one shared view about a passion for architecture and a passion for making the world a better place in which to live. That to my mind has been astonishing. So I want to one more time thank not only the instructors this year, and we couldn't have done it without you guys, but also the team that's behind us every single week, getting up sometimes at 6 a.m. to meet to discuss the future and so on. The passion that is there, it's not only is it kind of like amazing to see, but it's reassuring. You know, I think our future is in good hands because some of the team we have exceptional members of the team, and I'm blown away by this. So I just want to say briefly to say that it would be great to have a few words from various members of the team, and I want to invite our team individually to say something in their own language, if they might, just to say something about Digital Futures and about the message and their vision of the future. So I don't know, maybe Ahmed, I could ask you maybe to kick things off.
Thanks. Yeah, thanks for inviting me. Hello everyone. Hello my dear friends, colleagues and lovely students. أصدقائي الأعزاء وأبطال اليوم والمستقبل. I'm أحمد حسب, Africa Regional Manager Inclusive Futures 2021. أنا أحمد حسب, مدير الإقليمي لأفريقيا 2021 لمؤتمر Inclusive Futures. I believe that this is beginning of something great. Building bridges between different cultures, something may change the world and its perspective of humanity, not just education. It is time for solidarity and bring humanity together. It's a call for a change. It's for you to start learning and earning the proper knowledge to build a better future for everyone. أنا أؤمن إن دي مجرد بداية لحاجة كبيرة. بناء جسور بين الثقافات المختلفة هتغير العالم ونظرته للإنسانية. ليس التعليم فقط، ولكن ده وقت الاتحاد، دعوة للتغيير وبدء التعليم والتعلم واكتساب المهارات. Changing the world isn't an easy challenge, but we started and will never stop. Digital Futures believes in you, so please believe in yourself and start earning by learning. تغيير العالم ليس بالأمر السهل، ولكننا بدأنا ولن نتوقف. Digital Future تؤمن بك وجاء دورك أن تؤمن بنفسك. This year, Digital Futures managed to include as many as workshops as possible in different languages and time zones with a variety of levels from basic to advanced, from online to hybrid. We managed to facilitate the learning materials for you. So it's your turn now to learn and share with everyone willing to learn. هذا العام نجح الديجيتال فيوتشر في احتواء العديد من الورش بأقصى قدر والعديد من اللغات والمستويات من أقل حاجة لأعلى حاجة ومن الأونلاين إلى التنفيذ. يسرنا أن نقدم لك هذه المواد التعليمية وجي دورك تتعلم وتشاركها مع الجميع الآن. Thanks for everyone.
Thank you, Ahmed. Maybe, I don't know whether Cena you'd like to say a few words, because you've been the fundamental part of the core team for some time. Cena.
Thank you, Nila. For sure, I can also add a word. من فکر می‌کنم که پلتفرم دیجیتال فیوچرز یک فرصت خیلی عالیه برای تمام ملت‌های دنیا و به خصوص ایرانی‌ها. خیلی مفتخرم که جزو این گروه هستم و امیدوارم که راه دیجیتال فیوچرز در وادی‌های دیگه هم ادامه پیدا بکنه. Back to English, maybe I can also say some few words. Hello, Alemal. And I can also maybe, I was not prepared first of all for this part of the speech, but anyway, I can also maybe add one Persian poet, Sa'di, which somehow also kind of covered this idea of sympathy. So I will also would like to read that. Human beings are member of a whole in creation of one essence and soul. If one member is afflicted with pain, other members uneasy will remain. If you have no sympathy for human pain, the name of human you cannot retain. And I'm sure the fact that the of this poem might be questionable in today's world where everything is more horizontal. We need to live closer to nature, but I think this sympathy, a rhizomatic way of structuring our society, is something that we need to do more. And I'm happy that in Digital Futures we have tried that, and I hope we can continue this beyond the capacity of this very group that is sitting today, and that this can continue forever. Thank you.
Thank you. Merci, Cena. Very beautiful. Can I maybe call upon Chao to say something in Chinese? The Chinese community members.
Okay. Thank you, Neil. Well, for that I will say in English and then I turn it into Chinese. Well, I just want to add one more thing. Although we call ourselves Digital Futures, but we also value our very much. And like since 2011, when Neil and Philip collaborated together to start this journey, we have been kind of organizing physical workshops for almost 10 years. Well, then, the COVID came and went online. But for this year, with the support from the university and also the Tongji Design Institute, we have the opportunity to kind of organize some physical workshops again, trying to retrieve those kind of communications, interactions, or those kind of energies within a physical site. So in the end, besides of thanks to all the instructors and all the participants, I want to say two more things. One is follow us for our physical exhibition, which will be open on July the 10th. And then more importantly, I want to say, I hope the COVID will end very soon and I can see you all again in Shanghai next year. 我刚才所说的就是，虽然我们叫我们自己叫数字未来，但是其实我们对于我们自己的这个10年以来或者11年以来发展出来的这个传统，其实是非常非常珍惜的。从这个2001年，袁峰教授和这个尼尔里希教授他们开始合作去组织这些线下工作营。我们已经组织这些快将近10年了，然后去年因为这个疫情的原因，我们转到了线上。但是今年我们又有这个机会去重新去举办了一些线下工作营，然后去尝试去可能用一个不太恰当的词，就是去找回那些在一个线下场地当中的这些能量啊，这些交流啊，这些互动，这些非常非常有价值、非常重要的一些东西。所以我最后只是想说的是，第一点，我们7月10号会有这个线下工作营的 这个展览的开幕，然后请到时候来看我们的这个开幕现场。然后另外一点就是我希望这个疫情可能快结束，然后我们可以再次在上海再重聚吧。大概就是这样。好，谢谢。
Thank you. I don't know whether we're going to be able to get through, but Antonio Bonacci is here, and I want to try to invite him to say something in Italian. I think Antonio is somehow represents everything. He was teaching in Thailand before he came back to Europe to teach in Denmark, and he's from Italy himself, and I don't know where he is now. But Antonio, welcome.
Hi everyone. I'm actually in Berlin at the moment. Well, it's very nice to see like the event, how it unfolded, and amazing like the reach. I also participated this year by giving one workshop when last year I was a participant, and it was really nice to see how many people from very different places were taking part. By chance today I bumped into one of the participants in my workshop in Berlin because we went to the same exhibition, and so it's very nice that it also happens that what happens in digital futures in very different places in the world then sometimes also connects us in real life. In italiano posso dire che Digital Futures è di quest'anno è un evento talmente orizzontale, talmente aperto che fa pensare che ci sono degli aspetti di questa pandemia che hanno portato ottimi risultati anche in termini di inclusione. Thank you. Bye everyone.
Grazie mille. I'd like to bring in Mohamed Beju, who is part of the young, just coming into the team, and somebody kind of full of enthusiasm for the future. Mohamed.
Thank you, Neil. Hello, everyone. Hello, Neil. I should first thank every member of this amazing team, Digital Futures team. And as Cena mentioned that poem, I think the core idea behind all these efforts and passion everybody has in this team is that we are parts of a bigger whole. And I think these amazing people that came together in this team, in Digital Futures team, they want just to democratize architecture, education, and they want to make change. They want to make a change. This is so beautiful. This is inspiring. من از همه دوستامون تو دیجیتال فیچرز تشکر میکنم واقعا، چون که یک امکانی رو در اختیار همه ما دارن میذارن که میتونیم از ایده های افرادی که خیلی خبره هستن تو زمینه‌ای که ما علاقه‌مندیم بهش استفاده کنیم و این دموکراتیزه کردن آموزش، دموکراتیزه کردن طراحی، معماری، هر چیزی که ما بهش علاقه داریم و باعث شدن و خیلی الهام بخش این کار که می‌بینیم از سراسر دنیا آدمای مختلف دارن جمع میشن و این امکان رو بقیه میدن. So thank you, Neil. That's what I want to say.
Merci, Mohamed. Just you don't say they, say we. You're now part of the team. I wanted to just call upon some of the kind of the longer term members who've been here for a while. First of all, let me mention we have a couple of other team members who are unable to contribute today because, well, to begin with, Aya is recovering in bed from COVID. We wish her well and hope that she's recovering too. And Marina is also unable. She's here with us, but unable to say anything at the moment. So Marina, also get well soon. Let me invite Biana Bogosian, who I think also in many ways represents the kind of the way that we operate. Brought up in Iran from an Armenian family, she's now based in the States and connecting all over the world. So Biana, welcome.
Thank you so much, Neil, Philip, everybody that I've met through Digital Futures since 2012. along the way, students, other faculty, and a team that I've been working on behind the scenes, either in person in Shanghai or online. Some of you I've never met, but I've developed, I would say, strong friendships and research collaboration since. It's been an honor, and I'm also very proud having a hybrid background, that actually there is high representation from Iran, but also tiny country of Armenia. So let's build the future together, and thank you very much.
Thank you. Was that in Armenian?
Yes.
Yeah, wonderful. Thank you. Thank you. So let's move on to Gustavo, somebody who actually joined the team after last summer and has been a linchpin, I would say, in making everything happen. Gustavo, we all know how much you put into it. Thank you so much for your incredible contribution. Thank you.
I wanted to firstly say that I'm very thankful and humbled to be here. It was a call to action. I want to thank Philip and Neil and the team. Muchas gracias por todos mis compañeros. Thank you for all of my teammates. The only thing that I can say, it's changed my life, and I hope that there's more change to come. And as a recent graduate with my PhD from the Media Arts and Technology program, I can only say that I hope that there's more change coming forth, and I'm so humbled to be here. So thank you.
Thanks, Gustavo. It's good to hear a Spanish voice.
Yeah, I think.
Can we just ask Virginia to say something to round things up? Virginia?
Yes, I'm here, and of course I'm here on the Digital Futures account because I've been running everything behind the scenes, streaming all these events, and teaching a workshop also this year. I have to say Digital Futures has really managed to help me grow, and I've seen others grow with it as well, because I came to Digital Futures as a PhD student, not knowing at all what I was getting into, but really starting out by taking a workshop back when it was physical in 2019, and starting to organize the workshops last year in 2020, and this year teaching a hybrid workshop with Yiga Liu. And so it's really been amazing to see myself grow, but also see my colleagues and teammates also grow as we work together on this initiative. So I can't wait for the future of Digital Futures. Thank you.
Thank you, Virginia. I think we can see you make a really good progress, not only learning 2 years ago, but this year you're teaching fantastic workshop with Yiga Liu from Southeast University. That's great. So I want to add in one more special guest today, Klaas. Are you here?
Yeah.
Klaas,
can you hear me?
Hi, welcome, welcome. Klaas is actually the CEO of Bollinger from Europe. And he is actually organizing a fantastic workshop inside Bollinger. I was invited to make a speech there, but I think you make a quite amazing workshop. So it's a great honor to have you here, and try to invite you to join Digital Futures platform in the near future. Would you like to say something, Klaas?
Well, I already said so many times, so it's fantastic, of course, and the way you guys do it, it's very funny. The only fact that I have to regret somehow is that it's now 2 years in a row that we had to do it digital. So I'm much looking forward to do this physical again, and to get the energy back from all these people. I think it would be really. No, I'm much looking forward to see this amazing group that you gathered somehow, to see them all physically, to exchange really one-to-one, because this is something I've been missing a little bit last week. So Philip, when you were on the workshop in Versailles, in the end we did see all the students, and it was really nice to see them back. They all built physical models, and I have to say this is also why we do this, right? We want to see the students succeed, and they are the future. We can only help them actually so much. And I have to say also the people that were in our Caramba and Octopus workshop, this week. I've only been there 2 times listening in and then giving a small lecture, which was really nice. You see how many people are engaged to learn and to see new things. I mean, if you imagine that all this is at hand to go for new stuff, brilliant. No, we can only say that there's a bright future, I guess. And Philip, again, thanks. Neil and the whole team, thanks for organizing this. Let's see each other soon back. If anyone is coming to Paris anytime soon, just give me a message. I'm around, happy to have a chat around the coffee again on the terraces in Paris, which are world famous. So you can do it. You can come over. It's nice. Je vais pas parler en français, or maybe a little bit in French, but I can speak Dutch too. So I don't know what you prefer actually. So let's keep it in English, right?
Both.
Cool. Thank you very much, everybody.
Thanks a lot to class. Really good to see you again on this platform. And I would like to also introduce another very special volunteer and organizer in Digital Futures, Nick Bao. Nick, are you here? Nick is actually the young generation who is growing super fast in Australia. So Nick, would you please introduce yourself and say something?
Hi, yeah, thank you. Thank you, Professor Yuan and Professor Neil Lynch for invitation. Since I joined the Digital Future from 2019, I also start my PhD from 2018, and now it's 3 years. And also I grew up and also promote to the permanent faculty at MIT Architecture. So it's very honored to be one of the member of Digital Future. Also, Digital Future helped me to grow up very fast in the past 3 years. Thank you.
Philip, one person I meant to invite also was Daniel Bolajan to say something. Daniel has done an amazing amount of work, especially last year, but has been instrumental this year.
Welcome, Daniel.
Hi, everyone. So yeah, I think for me, I'm quite new to Digital Futures. I think I just joined the previous year when we went full online. So for me, the experience, it was amazing until now. And I think my cat again, it's all the time when I start talking, he's saying something. Yeah, for me, the experience was amazing. I mostly was involved with Digital Futures to organize and also give a workshop also last year and also this year. And it's great to see in a way the enthusiasm in a way for technology and architecture, which is my main focus of research. And I think it's an amazing in a way platform that I think many students around the world are going to appreciate. In Romania, for example, this is one big challenge, like access to this kind of information. It's a big challenge. And in special, like how to apply this kind of technologies in architecture, not necessarily just the tooling side of things. So from that perspective, I think Digital Future really makes a huge difference in Romania, which is an amazing thing for me. Thank you, everyone. Thank you, all the organizers. I know what it takes to organize this event and the amount of work that you put in. This year, probably I was not that involved like last year, but really congrats to everyone that was involved this year. And thank you everyone for all the effort that you put in to make this possible.
Just what I wanted to add something to Daniel's thing. Years ago, I gave a lecture in Iaminku, and I had no idea who was in the audience, and I was trying to share my enthusiasm for work that we've been doing at the time. And unbeknown to me, Daniel was in the audience, and something happened to change his life. And I was just reminded in a way by that, because Maya Mistry, who was also teaching a workshop this year, the same thing happened to him last year, in the sense that he attended an AI conference, AI workshop, and things will completely change for him. And I'm hoping that this will be also what's going to happen to some of the people on the workshop this year, that they will somehow their lives will have been changed in some ways. I'm wondering whether Cora might like to say something. She's been a fundamental team in the background. I don't want to put her on the spot, but if you're ready, if you would like to say something, Cora, please go ahead. But if not, don't worry. Okay, I think maybe Cora's unable to say something. Finally, let me just invite anyone else who want in the panelists today to add something. I don't know whether anyone hasn't spoken before, because it's a team effort. I don't know if anyone would like to say anything.
I would like to thank you and thank everyone, sir, for the continuous effort.
I always, don't call me sir. I mean, we're a team together, right? We're all equal. So, but anyway, thank you, Ahmed. It's a joy to be able to wake up at 6 o'clock in the morning during the winter and to see you in Cairo and to connect with everyone all over the world. I think that Philip.
Yeah, one more thing I want to add, because although all the workshops already finished, it's great thanks to all the instructors. At the same time, we want to publish all the workshop final presentation on the website, on the digitalfuture.org, or in the future will be digitalfuture.org, and for all the workshops. So I would like to asking or calling for all the workshops, turning the final presentation panels to the info of Digital Future box, and we also want to make another physical exhibition in Tongji exhibition hall of CUP here. So that will be the exhibition will be held 1 week later. So welcome turning your panel final results. So that's a great thanks to all the regional coordinators for Digital Futures. Thanks for your great efforts, and thanks to all the instructors, and including the organizers here in this group, and thanks a lot to all the audience and participants for Digital Future workshops. Thank you so much.
So this is the end of the closing ceremony. This is the end of the 2021 event, Inclusive Futures, but it's the beginning of something else. And I hope that we continue. I'm sure that we will continue. And I'm sure that we will continue with inclusivity as the heart of what we're doing today in the future. So thank you again. And thank you, team. It's a team effort. And it's wonderful to see such solidarity and incredible contributions from our workshop instructors and from the team helping it, and also to see so many people following our events. Thank you.
Thank you. Bye-bye. Ciao, ciao.
Thank you, everyone.
Thank you.
Bye-bye. Salam.
Thank you, everyone.
Thank you, everyone. Bye.
Thank you.
Thank you. Bye.